AI prompts, prompting techniques, prompt engineering, LLM prompts, or ChatGPT prompts. People have started to obsess too much over prompts or prompt engineering and project it as a difficult and vast subject. I agree that prompts are quite an important part of generative AI, and we need to learn them properly to work with AI. Again, creating perfect prompts is sometimes quite a tedious and challenging endeavor for complex tasks that need substantial expertise, time, and effort. But I think now a time has come to ask ourselves how much we need to learn or continuously update our skills in prompt engineering or prompting techniques, or whether to explore some alternatives to simplify or minimize manual prompt learning to ease lives. So, I am here again with a new video tutorial on AI prompting with a focus on breakthroughs in prompting techniques for exploring alternative ways from traditional manual prompt learning. To me, a beginner should have a basic education on prompting concepts and a few techniques of prompt engineering for a foundation, and acquire some practical skills and tricks to work on AI prompts. This will help to understand further new breakthrough techniques like prompts for reasoning by AI, meta prompting, or auto prompting to generate or automate prompting and prompting by AI agents. This video covers different sections which are organized in logical sequences with useful practical tips and references. Please watch this video till the end to understand it fully. But do not forget to like and subscribe to my channel. We are going to start with a very short video to give a brief overview of prompt and prompt engineering, followed by presentations on effective prompt design guidelines, prompt organizing tips, important breakthrough techniques with practical use cases, and the latest research references.
Welcome to our quick guide on basic AI prompting and prompt engineering. AI prompting is the process of providing specific instructions or inputs to an AI model to generate desired outputs. Prompt engineering is the art of crafting these prompts to optimize the performance of the AI. Let's explore some real-life examples of how AI prompts are used in various tasks. For text summarization, a prompt could be as simple as "summarize this article in 2 sentences." In text classification, you might use a prompt like "classify this email as spam or not spam." For conversational AI, a prompt could be "respond to the following question as a helpful assistant." In reasoning tasks, an example prompt is "solve this logical puzzle and explain your reasoning." For image generation, you might prompt an AI with "create an image of a serene beach at sunset." In audio generation, a prompt could be "generate a soothing background music track." Effective AI prompting and prompt engineering are crucial for achieving accurate and meaningful AI outputs. They play a significant role in various applications, from automating tasks to enhancing creative processes. As AI continues to evolve, mastering the art of prompt engineering will unlock even greater potential in technology. Start experimenting with prompts and discover the possibilities today.
In order to craft a perfect AI prompt, it is essential to know how to design effective prompts. Here, I am going to talk about a few important tips one by one for effective prompt design. First of all, think clearly. Figure out the actual requirements or the business needs. Provide better, precise, and concise statements as question statements or instructions. Format the prompts in a clear and organized manner to help the AI model understand what to do. Instruct the AI model to provide feedback through its questions, thoughts, or observations before giving, and evaluate and check the model for the expected or corrected result. Iterate or refine the prompt if necessary to get the perfect answer. For complex reasonings, instruct AI model to think or reason step by step by breaking it into down to smaller, more manageable pieces of tasks, and then give the observation and answer. Explore or make breakthroughs in prompting techniques for better results. You have come to know prompting is an important skill to learn, but you are not exactly sure why some prompts generate very generic outputs while others give you precisely what you are looking for. Here I am sharing the 7 elements or building blocks that make up a high quality prompt. 7 prompt elements are task, context, persona, examples, constraint, format. Element is classified into one of the 4 types: mandatory, essential, more accuracy, and optional. It is not only important to know the classification but also the hierarchy of the importance of this classification. Mandatory to have a task or job to be done in your prompt for AI to provide the desired output. It is customary to start the task sentence with an action verb like write, analyze, design, generate, classify, etc., and clearly articulate your end goal. Here is an example of task with action verb design. Context is an essential prompt element to get better quality outputs, but it has to be restricted with the task goal, user's background, and environment. Here is an example of context. Persona. You can think of AI to be a person with task related expertise to whom you wish to have instant task access and provide better results considering the context. Such role playing by an AI character can generate more contextually appropriate responses. Here is an example. Research on large language models or LLMs in AI has shown that including examples within the prompt drastically improves the accuracy and quality of the output. Examples can help them to learn AI and set clearer expectations on the job. More details on examples will be taken up in the later section on breakthrough techniques. Constraint is a simple boundary zone where you want the AI to stay within or the restrictions you only want results to remain. For example, design a course for high school students. Format. Visualize first how exactly you want the result to look like and then select the suitable format. Some of the common formats are table, email, bullet point, code snippet, and paragraphs. Tones are potential adjectives or adverbs for appropriate selections based on the expectations of the prompt responses. Here are a few examples of tone where tones are marked with yellow. Key prompt elements together, let's look at this comprehensive prompt example. Now we put the comprehensive prompt example in Chat GPT 4o and see the result. Here we get a nice report in tabular format as per input specifications through key elements. Next, see the difference in ChatGPT output if you use a very simple prompt with task only and omitting other prompt elements. To keep the prompt learning simple, I'll just let you know the basics of a few important breakthrough techniques with much wider scopes than earlier text-based manual prompting. This can better harness the potential and maximize the performance of large language models to give more accurate results without much botheration of perfect usage of prompt elements as in traditional prompting methods. Some newer LLMs have more reasoning capabilities that considerably reduce the task of manual prompting and are closer to how humans perceive the world. Let's now quickly dive into these techniques one by one. So far, we have learned about unimodal or single type test prompting. A useful breakthrough extension is multimodal prompting. Multimodal prompting refers to interacting with AI systems using multiple input modes or media such as text, images, audio, or video for a more comprehensive or context aware understanding and to generate useful responses. It finds useful applications in healthcare, education, agriculture, manufacturing, and more. A few important multimodal large language models are GPT-4o, Gemini, Chameleon, Claude 3.5, Sonnet, and Lava. Now, I will give a simple practical demonstration of multimodal prompting using ChatGPT 4.4o. Here, I have pasted a picture of a cat and write a prompt in GPT-4o describe the picture and generate a better image and sound of the picture. Here is the description of the cat followed by the enhanced image and the generated sound. Reasoning a prompt. Several techniques are being explored to unlock the reasoning capabilities of large language models of AI with the goal towards the development of artificial intelligence. One approach is to use prompting strategies. A few selected important strategies are providing one or more examples in a prompt, single path reasoning, and multipath reasoning. Zero shot reasoning and few shot reasoning are two useful techniques for LLMs to reason and provide answers more accurately, though one shot and n shot prompting are also there. Zero shot model has no specific example or prior training and it uses pre existing knowledge. On the other hand, few shot reasoning gives the model few examples. Here, you want AI to help you to write an email to introduce your company services to the client. So here is the prompt: write a professional email introducing our software development company to a potential client, mentioning that we specialize in custom app development, have experience with both iOS and Android platforms, and offer full cycle project management from design to deployment. Here is the output generated by GPT-4o for zero shot reasoning. Here, a real life example of few shot reasoning. Here, the prompt is: here are a few examples of social media posts we have written for our client, a fashion brand promoting their new clothing line. Based on these examples, generate a new post for their upcoming fall collection launch. The previous examples gave it the style and structure to follow, but it still created new relevant content using this context, which is the essence of few shot prompting. Single path reasoning. Or linear reasoning is a sequence of reasons or thoughts that follow one after another in a single path. Chain of thought or COT is one important example of single path reasoning. It is a series of intermediate reasoning steps that significantly improves the ability of large language models to perform complex reasoning. The model follows a series of steps in its reasoning to answer the prompt. A few practical applications of COT can be arithmetic reasoning, common sense reasoning, question answering, and sentiment analysis. Here is a real life professional example of chain of thought in legal document analysis using ChatGPT o1 Preview, a recent AI language model. A prompt: read the attached contract and identify any clauses that could pose risks to our client. Provide a step by step analysis of each risky clause and suggest possible revisions is submitted to the model. From the output, we find that the model analyzed each clause systematically to mitigate the potential risks that help the law firm with effective decision making and negotiation strategies. React, Reason and Act is a novel prompt based paradigm that synergizes reasoning and acting in large language models for general tasks. React builds on the concepts of chain of thought prompting techniques and guide models through a sequence of steps to arrive at a solution. A combination of React and COT that allows for the both internal knowledge and externally obtained information during reasoning. React follows three key elements: thought, action, and observation. Thought represents a logical step in the decision making process and demonstrate how to approach a problem. Action instructs the model on how to proceed, allowing the model to interact with external resources or environment. Finally, observation results produced by the environment. The observations become crucial input for further reasoning and decision making. Here is an example of building a house with thought, action, and observation. Multipath reasoning. Human thoughts and reasonings are dynamic, where the flow of reasons is often nonlinear due to new or change in the thoughts. This leads to multiple reasoning paths, which can be modeled through tree of thoughts and graph of thoughts. Automated prompt engineering, or AP, is a technique to automate the process of generating and refining prompts for a large language model (LLM) to improve the model's performance on a particular task. It uses the idea of prompt engineering, which involves manually crafting and testing various prompts and automates the entire process. AP allows us to automate the process of prompt optimization and tap into unlocked potential for our LLM applications. Breakthroughs like automated prompt engineering could become standard practice in the years to come. Have a look at the APE workflow diagram. The process of generating responses, evaluating them, and optimizing the prompt, steps 3 to 5, is repeated iteratively as shown in step 6. With each iteration, the prompt gets refined, leading to better and better responses from the LLM. After a certain number of iterations, or when a satisfactory performance level is reached, the best performing prompt, along with the scores of all prompts, will be sent back to the user. Metaprompting is a branch of prompt design that focuses on prompts that write other prompts. The process entails utilizing language models to interpret input strings as instructions and consequently generate prompts that guide further tasks. This allows an AI to tackle multi-step problems by writing subsequent prompts. It also saves you time when you write prompts. The modus operandi of metaprompting is to use a model to coordinate and execute multiple independent queries and subsequently synthesize the responses to render a final response. Metaprompt can ask LLM with good reasoning capabilities to write a new prompt based on prior context, that is, previous prompts and their performance metrics, to improve LLMs to propose better or improved prompts, as in automatic prompt optimization or engineering techniques. Key elements of metaprompting for complex reasoning. There are four such elements. First is complex problem decomposition, then detailed preliminary content, then step by step problem solving, and final solution presentation. Here is an illustrative example of a system generic metaprompt for solving a wide range of reasoning tasks. This metaprompt can be seen as the generic type metaprompt that fits most tasks. The detailed instruction is provided within the triple quotes. A list of few useful and relevant research papers and blog posts are given here for detailed study and deep understanding. I have borrowed few diagrams from some of them for use in this video tutorial. Hope you have gained some value-added insights on AI prompts and its future, and like and subscribe